Welcome to this new video about natural language processing and artificial intelligence, in which I want to give you some explanation about the concept of embedding and vectorization. So this is a very, very hot topic of the moment. Everyone is talking about vector storage, but we need to understand where does it started. And it started all with an experiment called Word2Vec, where we wanted to try to train a neural network to assign to a word a vector, where a vector is a sequence of number. It's a linear algebra, so we can do operation with vectors, subtraction, multiplication. And the idea is to be able on training, to train a neural network into assign vector to word, and this vector should have some sort of meaning, some form of meaning, to just verify that the neural network didn't produce garbage. You will find some links in the description below to the video where I link you some interesting resource that goes into deep detail on how this neural network was trained. For now, I just want to give you some experiment and some live Python code that demonstrate something that demonstrate that the neural network really create vectors that capture semantic. And one of the most famous experiment, I'm sure you've heard about this, it's taking the vector of king, subtracting the vector of man, adding the vector of woman. So basically we are telling from the concept of king, remove the man part, add the woman part, and then let's try to find which is the nearest vector in the vector space of Word2Vec nearest to the result, and the result is queen. So it is intuitive that when we have king, we remove the man and we had the woman, we had a queen. So this experiment showed that indeed this neural network capture some semantic of the word. So the number, the vector that is assigned to each word capture the semantic of the word. So in Python, as you can understand, there is a library that contains this experiment. So these simple pieces of Python capture the model, so capture all the weight of this neural network and let you experiment with the results. So let's dive into code to verify ourselves that what we read in the paper is indeed correct. Once you loaded the model dumps some information about the model itself. I'm not interested in this. Let's see how we can perform basic operation to verify that indeed queen is the result of king minus man plus woman. And I've added some other example that you can find in the internet because it does not work for every word. These are 3 examples where we can use the GenSim library to simply operate on the weight of this neural network of Word2Vec to verify what we are seeing. And so let's see the first example. We have the most similar operation that find the most similar vector inside the model of king minus man plus woman. So the operation are commutative. So it's not important that I do king minus man plus woman or king plus woman minus man. So vector space, linear algebra, operation like addition and subtraction are commutative. So I have this simply most similar that takes positive and negative vectors. And so I run this and I print the first 5 results. And indeed the first result is queen. Then we have a monarch. Then we have a princess. Then we have a crown prince. Then we have a prince. So you see, all these vectors are near in the vector space of Word2Vec. And this is interesting because it demonstrates that it's something that it captures some meaning of the word. Okay, so king, prince, crown prince, princess, queen are all vectors that are near in the space. Then we have other example like France minus Paris plus Tokyo, and the result is Japan, Osaka. So you can see if from the concept of France you remove the capital and you add the capital Tokyo. So the idea is France minus Paris minus capital is the idea of the nation. If you re-add Tokyo, you find Japan. Yes, it's interesting. And you can do the France, Paris, and Rome. And what you got is Italy, European, Italian, you see Spain. But this is really interesting because it demonstrates really the ability of a neural network to be trained on a large amount of text and capture the meaning of words. So the idea is that we can perform the same operation, but instead of taking one word, we can train a neural network to take a sentence, a pieces of text, and extract the vector of the embedding. And the idea is that the vector is capturing the concept, the context, what the semantic of the piece of text. And this is useful in natural language processing because we can use these things to verify from a large corpus of text. We can divide all the text into chunks, and then we can see if a chunk is similar to another, comparing the vector. And this is a real key change in natural language processing. But to verify this, let's try to use the same example of Word2Vec, but this time using a model that is trained for embedding. So what I'm using is a model you can find in Hugging Face, is the Distilbert multilingual cased one. And it's a model, as you read in the description, that is made to capture the concept of a paragraph of text. But instead of using like you find in example, as in the sentence transform example, I'm going to do the very same experiment of Word2Vec. I will download a dictionary of word. I will transform each single word with this model that can transform pieces of text, a complex piece of text, but it can transform only a single word. And I'm going to demonstrate that even with this model, something of this analogy still functions. So yeah, the concept of being able to capture semantic from text to vector is a concept that it's working and it's gonna change the way you are searching things inside your data structures, database, everything. The first part is downloading the model using the auto tokenizer from pre-trained, passing the model name. So this is really simple. The first time it will require some times because it will download all the weight of the neural network of this model from Hugging Face and store to your hard disk. And then I'm simply define a cosine similarity function. But this is not important. What is important is how I'm going to transform all the words inside vector with this model. So first of all, I download from a file on GitHub a dictionary of English words, okay? So I have lots of words loaded into memory, and I have, as you can see, a large amount of words. And now I need to transform all single words into a vector using the Distilbert model. And as a disclaimer, I'm far from being a torch expert. So I've wrote this code and I got it wrong the first time because it had a memory leak, and so it's going to error because it saturates all my GPU memory. And thanks to generative AI and Copilot, I was able to simply ask to Copilot, where is my memory leak? And it suggests me that I forgot this detach here, okay? So this code is quite simple. It works in a batch and it's using GPU. So it's using a batch size of 512 words, and it's using Torch to run this model and to store all result inside the word embedding. So if I'm playing this thing, it is start working, okay? And if I'm going to open a task manager and showing performance, my GPU, you can see that my GPU is pretty much loaded. So I'm using my GPU to run this model in Python using Torch, transforming all the word of the dictionary I've loaded in memory into vector using Distilbert model that I've downloaded from Hugging Face. So actually, I'm creating an in-memory representation of the vector. It is highly inefficient. I don't care about this. It's just for purpose. I'm using a lot of memory because I'm storing everything into memory. I should have used a vector database, but it's not important. What I want to do is understand if using a different model, I can get the embed of single words and try the same analogy of king, queen, and verify if they are working. Once I've transformed all the words, I can simply print the first element that I got in word embedding array, and it's a tensor, okay? So it works. It's a tensor containing a vector. So this is the representation of the first word in my word embeddings. Now, I have another pieces of the puzzle. I create a function that is called find similar words, in which I pass a source word, a subtract, and add. So the purpose is I want to take the vector embedding of the source, subtract the vector embedding of the subtract word, and add the vector embedding of the add word. So I tokenize all three, okay? And then I go into the output. So I got the source, subtract, and add tensor from the 0, 1, and 2 position. And I go to simple math operation like source tensor minus subtract tensor plus add tensor. And then I torch stack all the word embedding that I've calculated before. And I'm doing a very brute force looking in memory for all the previously calculated words. And so I find the word similarities, okay? And I have my word embedding tensor. And so what I have is the difference between the resulting vector to the all original vectors for all the words. So the purpose is with this code, I'm able to compare the vector that is resulting from this operation to every vector of the original words in memory. And then I'm sorting in to find the most similar, and I'm print the first 10. So this is some torch code I have written with the help of Copilot. So it's, as I told you, I'm not a torch expert. I'm primarily a C# developer. And writing this code, I trying to do the very same operation I've done with Word2Vec. So find similar words for king, minus man plus woman, and if I press play, it really need a very small amount of time because I have my GPU that is calculating everything. And even if I have almost 500,000 vectors, it's really, really quick. And yes, I have a similar result. Queen, Regina, Queena, King Ridden, Queenhood. Okay, all these are words from my words file that I've downloaded from GitHub. But it works. I can use France, Paris, and Tokyo and try to verify if the result is the same. And I'm still getting Japan, still Tokyo, Japanese, Japan, Tokyo. So it seems to work. So the conclusion is yes, in the latest year, because Word2Vec is from 2012 around, and in latest year, we developed and we trained a lot of neural network, a lot of models that are capable of taking a pieces of text or a single word, transform into vector, and this vector is containing the semantic of the word. And this is useful because we are using this neural network, these models, to help us in searching things inside databases and in a very different way than standard keyword search. We can do some sort of semantic search, and this is changing the way in which we are approaching the natural language processing landscape. And I hope this video I hope you enjoyed this video, and I'm waiting you for the next one.